Assalamualaikum. We are from Group 9. We'll be presenting our CDIO project proposal, Move2Talk. Firstly, let me introduce our group members. I am Hana Humaira, the group leader. Our secretary is Nadia, treasurer Izzati, and IT officer Sajida. Next, this is our table of contents. To start off, project background. In a world predominantly designed for the hearing, life as a deaf and mute person is inherently challenging. There are approximately 40,000 registered deaf and hard of hearing individuals in Malaysia. Most of them use the Malaysian Sign Language, or also known as BIM, short to Bahasa Isyarat Malaysia, to communicate. However, it is estimated for every 800 deaf individuals, there is only one Malaysian Sign Language interpreter, indicating how little exposure and usage of it in communicating in the daily life within our society. This signifies that communication has always been a persistent barrier for these individuals for as long as we can remember. To continue, Move2Talk contains three main project motivation. The first is language adaptation barriers. Users face difficulties as they need to relearn a different sign language to operate the glove effectively. Second is insufficient glove availability. There is a lack of gloves specifically designed for Malaysian Sign Language (BIM), which is not inclusive to the local community. And third is glove accessibility constraints. The current marketable gloves are predominantly accessible only to those with higher financial status, posing limitations for the others due to its high cost. Hence, our project objective is to develop a glove-based device that translates finger movements into text-to-speech, which support the following key features. The first one is tailored technology designed specifically for Malaysian Sign Language community. This brings the inclusivity and defeats the idea of relearning a new sign language just to use a device in helping to communicate better. Second, it also provides a cost-effective alternative glove accessible to all, so that none will be left out. Moving on to the project scope. Move2Talk is a glove-based device that converts finger movements into electrical signals, subsequently translating them into text-to-speech. The input specification includes the flex sensor, which will measure the bending of the fingers in between 0 to 180 degrees, which is then transferred to an Arduino Nano and displayed on both the LCD display and Bluetooth connected app. Next, our targeted user is for the deaf or hard of hearing individuals, specifically BIM users, regardless of financial status. However, there are some limitations. First one is this device only facilitates one-way communication. Second, this device is limited to interpreting finger movements only. So, movements that includes palm, wrist, or the whole hand movements are undetectable. Third, this device is unsuitable for prolonged usage at a time due to it might be uncomfortable for the user.
Assalamualaikum and hello everyone. My name is Nur Nadia binti Mustafa. So I will present the project methodology of our product. So first of all, we start with the project flowchart. So for cycle 1, firstly we have our idea brainstorming and finalization. Then we have our detailed discussion and planning, and then proposal preparation, proposal presentation, and then lastly is proposal review and submission. Then for cycle 2, we have our hardware assembling and development, and then software coding and simulation. Then we have prototype, troubleshoot, and submission of cycle 2. When we move to cycle 3, we have our hardware and software integration, final prototyping, system functionality verification and testing, project refining, product demonstration, and then final report. Next, for task delegation, we have divided the tasks equally for each member of the group depending on the cycle and on the chapter. So first of all, for cycle 1, which is proposal, we have done the idea brainstorming and finalization and also detailed discussion and planning together before the proposal preparation. So move on to the proposal preparation. For chapter 1, the person in charge is by Hana Humaira. For Chapter 2 is done by me, Nur Nadia, and Chapter 3 and Chapter 4 is done by Izzati and Sajida. Then move on to Cycle 2 and Cycle 3. For Cycle 2, which is Progress Update, we will done the hardware assembling and development part together. And then for the software coding and simulation, we divided the task for flex sensor activation is by Sajida, Bluetooth module is by Hana Humaira, LCD display activation is by Izzati, and interface for Android app is by me, Nadia. And then we will do the troubleshooting, testing, and progress update presentation together. Then for Cycle 3, which is demo pitching, we will do everything together, which is hardware and software integration, software functionality testing and verification, project refining, product demonstration and pitching, and also final report. For Gantt chart and milestone, we plan that the idea brainstorming and finalization should be done in week 5. Then the detailed discussion and planning should be done in week 6. And then the proposal preparation, which consists of Chapter 1, Chapter 2, Chapter 3, and Chapter 4, should be done in week 6 and week 7. For Cycle 2 and Cycle 3, we plan that the software coding and simulation should be done in week 7 until week 9. And then the hardware assembling and development should be done in week 8 until week 10. For the troubleshooting testing is on week 11. And then slide preparation is on week 11 until week 12. And then the presentation is on week 13. Then move on to Cycle 3. The hardware and software integration is on week 12. The system testing is week 13. Refining is on week 14. Documentation is on week 14 and 15. And then lastly, the demonstration is on week 15. Last but not least is budgeting. We have listed down the component, unit price, quantity, and also the price of all the electronic components that we use in our product to make sure that our product is functioning well. So, the total of the electronic component that we need to buy is RM127.90. Then, we also include other item in our budgeting, which is manpower, all 4 of us, testing and verification cost of the product, additional and hidden costs. Then, after calculating, we get the total cost is RM207.90. Then we discuss the expected selling price of the product is RM250 with the profit 17%.
Assalamualaikum and hi, my name is Nur Izzati Fikir binti Zambi and I have been assigned as treasurer. In our structural block diagram, the inputs is flat sensor and the Bluetooth module AT09. Then we will use Arduino Nano ATmega328P. For output, we have I2C LCD display and the Android apps. For the next part is system workflow. Glove will function when there are movement of the fingers, which is thumb, index, middle finger, ring finger, and little finger. Next, the flat sensor will detect degree finger when it will either a letter or a number. And after that, it will be displayed on the LCD display. At the same time, the apps will convert it to speech so that normal people can hear it. We put some delay so people can read and listen to it. After that, it will repeat it again and again. And if there are no movement, the glove will off.
Greetings and Assalamualaikum. I'm Sajida. Now I'll describe the front-end analog circuit. This schematic diagram illustrates the connection for analog circuit comprising 5 main components: Bluetooth module, transmitter, Arduino Nano, flex sensors, resistors, and LCD. The Arduino Nano serves to provide additional analog pins since we're employing 5 flex sensors to stimulate all 5 fingers. We've opted for an I2C LCD due to necessity of SCL and SDR connections for Arduino. Furthermore, the Bluetooth module is integrated into the circuit to establish a connection with an Android app on a phone. Flex sensors function as variable resistors with changes in resistance corresponding to the degree of finger bending. Arduino Nano boasts 14 digital pins and 8 analog pins, all programmable for input and output operations. Bluetooth enables data exchange between devices and facilitates serial communication. Resistors are used to form a voltage divider, converting the variable resistance of a flex sensor into variable voltage. LCD displays support an Arduino library, simplifying the integration of graphic and text display. Next, let's move on to the back-end digital processing design and development. In this flowchart, as we can see, the variable, pins, serial communication and software serial are initialized. All 5 fingers are declared into different variables since the flex sensor are connected to Arduino. It is declared as analog read on each pin. The program will read the analog sensor if there is degree movement on fingers. For example, number 1. The program will detect the bending degree on thumb and other 3 fingers to print the number on LCD. The same process is repeated for other numbers as well from 1 to 10 and alphabet. On the next page, with the connection of Bluetooth module, the Android app will also display and speak the display word on the phone. A delay is set for easy reading in communication. This program applies looping process as it will continue display until the phone is switched off.
Next, we go to the conclusion. There are 2 projects significant. Firstly, it will facilitate communication accessibility for deaf-mute community in Malaysia, which can indirectly help elevate the psychological, educational, and social challenges in this community. Next, it will act as a bridge between the deaf-mute community and society by dismantling obstacles frequently resulting in social isolation. On the other hand, as for the project benefits, it will strengthen connection between the local community and deaf-mute individuals. Second, it will spread awareness of Malaysian Sign Language to the worldwide. And lastly, it will boost the amount of individuals who are proficient in sign language. This is the reference that we use in our project. Okay. That's all from us. Thank you.